Raphael, I cannot get away from food and beverage executives. You know, this whole time you and I have been talking about Tecton in this really interesting, you know, I'm a non-engineer, so you've got your hands full today to try to explain this, you know, incredible brain that you've made for machine manufacturers. But lo and behold, you are a food and beverage entrepreneur, investor of a cafe in Armenia. How in the world? I feel like everyone, so many entrepreneurs gravitate toward food. How did you decide? How did this even happen for you? I did years and years of food and beverage podcasting. I had no idea.
Hello, Tony. And I was not expecting to hear this question as the first kind of.
Yeah, how about that? We're throwing you. How about that?
Yeah,
we're
the
sitting
name
down
of
for a beer.
yeah, as the name of this place that we started many years back. It was like I think like 15 years back or something like that. It was called Anti Cafe. So it's not even food and beverage place. So it's not like a regular restaurant or a cafe. Rather, people were coming there to pay for the time they spent there, and they were like there are like many basically different types of games, board games, and they
I thought it
can
was a
work, they
cafe.
can
So
do So it's not a literally cafe, but rather it's called Anti Cafe. So that's kind of what it was, and it was many years back, and then we exited. Now it's still running with the team who were like the people who were running the company, our employees. Now they are still continuing to run the place. It's called Aeon. That's
Well,
it.
I
Like
just thought it was interesting because I was looking at your LinkedIn profile again, and I thought, oh, he was in a cafe. I was like, he was an investor in a cafe, and I thought this is kind of interesting because, you know, for years I did food and beverage podcasting. Well, that was an industry that we worked in for staffing, and I thought how interesting for you, this, you know, an entrepreneur, an engineer, very, very, very needed space that you're in. I was like, how in the world did you cross over? So it's not quite as dramatic as I thought.
True.
Okay, so
and actually, it was the first one in our city, and it was started by my co-founders, and I was just like a passive investor, I would say, not
I see.
any executive.
You're the money man. You were the money man. So, your background, we talk about engineering with Rafa Solutions, it was a systems integrator, and I think that's kind of where you got your ideas for Tecton.
Sure.
And I would like to, let's start kind of high level for a minute, because we've talked a lot about systems integrations here. From your point of view, from your slice of the industry, explain what systems integration meant for you and the company that you were working in. You were CEO or co-founder of Rafa?
Yeah. I was the solo founder for the company. And so basically the systems integration is when you have a particular problem to solve for customers. And those are the really diverse types of problems. In our case, it was from automotive, oil and gas, academia, different types of solutions that we need to supply to our customers. And those problems require integration of different technologies, both hardware as well as software. And our responsibility was to understand what are the challenges, what is the problem to be solved, and to find the right components and integrate all together and deliver the final solution to those particular customers. Just to give some examples, like one of the projects was a robot that goes inside the oil pipeline and was monitoring the health of the pipeline. Just to give a better understanding for our audience, what means systems integration from the perspective of Rafa Solutions. And that was a project in India.
Well, so literally you were sending robots down into the line to inspect.
Yeah, it goes inside, it runs with the pressure of the oil because like it's pressurized, it's actually, there was no motor inside. And then it was monitoring how thick or thin is the pipe, and basically recognizing wherever there is corrosion or some kind of anomalies. That's kind of how it was called. It was many years back, and there was no yet like even machine learning algorithms. So it was mostly pattern recognition to understand what is not the way it should be, let's say.
Yeah, the tolerances. Well, I mean, that's obviously a space that is uh, the risk return. It's a you have to have that. I mean, you're talking about millions and millions of lost revenue, not to mention the environmental impacts if something like that were to break. So then
Even
you
robbery, like attachments, they were
right,
taking oil out without the owner knowing about that. So that was also being detected by the system.
I see. So what was the impetus behind Tacton? How did you transition from one to the other, or is Tacton kind of a natural spin-off from Rafa?
Yeah, I think like from my perspective, it's very much natural. But the idea or the way it works, at least for me as a founder of Rafa Solutions, first of all, it's I think like with the same number of people, with the same team, we can actually deliver much bigger value to our customers, as well as I would say to a bigger audience, to the world. When you make a product or technology, and then you can leverage this knowledge and expertise multiple times, delivering the same solution to many companies. And that's what is product company. So that was, first of all, my desire to shift from service business, which is systems integration, is kind of service business because you build products every time from scratch for a single customer. And then in the case of a product or technology company or startup is like fast growing product company, yeah,
Yeah.
with some kind of innovation. So that's something that was exciting me. And then now the particular industry or the type of the technology that we decided to work on actually came from the field, from those projects that we were working on during Rafa Solutions time. So
This is
that's how we started.
a trend, a kind of a natural evolution I have seen quite a bit with consultants. A consultant has a great set of skills, but they don't really kind of own the outcomes in some ways, right? They come in, they like the integrator, we kind of look across, we put
It's similar.
together what,
Yeah.
yeah, very similar. I could see that. And one of the challenges that, eventually they feel like they
We can
want to
also
be
do the same. I mean, we can build the product.
yeah, exactly. Be more connected. And I think that's kind of what you're saying. You've really transitioned from service to product, which then allows for greater scale, greater impact. You can work with many more industries. So I know you're going to explain what Tacton is, but I thought this might be kind of a fun exercise for me to try to explain to you what I think this is. And then you can
So,
tear it apart. So machine manufacturers are faced with creating their product that they know that their end customer needs. However, every customer has a slightly different set of requirements. And we're talking about machines for factories, for it could be construction, agriculture, could be for material testing. And obviously the space you're in is for automation. So you're looking at your end customer, trying to determine what they need. Well, it's very difficult, very time consuming, costly to create all the different specs for every different company. So you have created this intelligent kind of brain, and we're going to be showing pictures and videos of this so people can see what this, like a board, kind of looks like. So the engineers can come in and kind of build with their own blocks, can customize the manufactured solution. Like, what signals does your machine need to collect? Okay, great. We can set that up for you, right? Like, what hardware do you need to control? Great. You can move these controls in place. So you're giving the engineers, the manufacturers, a little more control to create a customized solution that's scalable and quicker. That's about as much as I can describe of this. So how far off am I in this description?
I don't think you are far from the way I would describe. So it's a great job. I mean, I think you did a great homework, kind of investigating or learning about what Tacton is doing.
I'm
But there are
fascinated with
actually,
this because we live within robotics and machinery. It's, we're staffing workforce. So we work among all these things. So please tell us now.
I would like to start this kind of conversation or the description of Tactun from describing the market space where we are today and where we're moving, and then what's our role as a company, as Tactun, as startup within that market space. So it's all about robotics. And now, what is robotics? When everyone, like if you ask somebody on the street what is a robot, everyone will probably describe the robot as a Terminator or like humanoid robot. Like it looks similar to human body, and then they can do like it has got some intelligence, sensors and actuators, and it does some kind of a work. So that's what everyone realized from the very first shot. But in reality, the robots that will be around us and that are already running on different industrial environments are not always looking like human body or even dogs. Like let me bring examples. So, for example, in agriculture, there are going to be many different types of specialty robots, or sometimes called field robots, that will collect apples or some fruits from trees. And those are still called robots, but they look differently. Or robots that will be in energy field, in oil and gas, in renewable energy industry, or construction. Let's say in the future, instead of human, like today, many people are really doing like hard work, putting brick after brick, putting the concrete and like making a wall, like brick layering the wall that will be part of your house. Now, I believe that the future will be kind of helping, those robots will help humans to accomplish really dirty job, hard work, like cleaning toilets, or
Yeah.
like these are all still robots. Now, those robots are manufactured by machinery manufacturers or robotic engineering companies, and they need to do a couple. Their innovation is on the couple aspects. One of them is integrating the physical AI, which means how the brain of this robot needs to have a perception of the world, like understand the distance, measure the weight of anything, like because we our brain is working like that. When you see a cup, you can actually understand what needs to be the force if the cup is empty or is full. Now, like that's all the artificial intelligence helps to perceive the world and to be part of the game interacting in this world. That's one part. Now, what's our role? If I continue the conversation, what is the role of Taktun within this value chain? Okay, so should I continue, or maybe you have
I
some
think that's
additional
no, no,
questions?
no. This is a great setup. Continue.
Okay. Okay, so now if we go back to what Taktun does for those companies, for those machine manufacturers or robotic companies, is that many times when those companies start to build those machines, they spend months, sometimes years, on developing those PCBs, printed circuit boards, or those like that you have probably seen, like the black or
Oh
green
yeah.
color, and the purpose of the board is not only to have a brain, but even to connect with those different sensors and actuators, like motors,
It's like
like
the
those
nervous system. It's like the
temperature.
nervous system that connects to the
Exactly.
brain.
Yeah.
Yeah.
So what we do is, I would say, it's not even just the brain, but rather the spine. As if we compare with human body, the spine
Ah.
connects the sensors and actuators, like everything, like the neural network, and the brain itself is what NVIDIA does. Or I think, like our audience probably heard about one of the biggest companies, or even the
I
biggest.
would hope that my
Yeah.
audience not only knows NVIDIA, but they're smart enough to be investing in NVDA and all the other.
Yeah.
Uh,
So
yeah.
NVIDIA builds those chips that include the artificial intelligence or the brain for those robots to operate, to think. But then this NVIDIA Jetson or those kind of boards which operate, which think, they don't have the SPI, they don't have the connectivity to connect sensors or actuators. Now that's what we're doing. Now our platform is enough universal to handle variety types of work as per our customer requirements. And then they scale, they now, instead of spending 10 months or 1 year to develop those boards, they get the same result in a matter of a week or two. And that's
That's
kind of the
incredible.
magic.
That's scale. And you know what? That is
That's
what's
the value
needed
for
because
them.
we're talking about massive scale that's going to be coming in this space. And I'm glad you separated humanoid from non-humanoid because I wanted to make that perfectly clear. You know, we've had non-humanoid robots out for, decades. I mean, you just think back to the old automotive manufacturing lines, those giant arms, that's technically robotics.
True.
I think it's just become a little more fashionable to think about these, wild looking, well, they're kind of wild looking, those humanoids. So you're talking about the kind of uniquely designed robots for a function, for a specific function. And we are going to see the dirty, dull, and dangerous jobs being replaced with those. So you're saying what? So what is the speed of adoption? What are you noticing now? Is tracking your
Honestly,
sales
I don't
data and
think it's
interest?
very
What's
quick.
happening?
Yeah. In the technology is more advanced than the adoption is happening. I think and it's the way we work. Our brain works. Is many times we don't want to change. We don't want to use something in a different way, and because of this challenge or the situation that humans are not ready to adopt new technologies, the adoption is not happening quickly. I think, especially in field robotics, because most of these problems are currently solved by commodity or I would say incumbent companies. And people who are in agriculture, in construction, they are not ready or they don't know how to use this new technology. And because of these reasons, not only because the technology is not ready, the adoption is going to take maybe 5 years or even 10 years. And that depends on the industry. I think healthcare is quite advanced, and we may see quite a lot of innovation in healthcare, in surgery, and robotics for surgery. When we go into more mass markets like construction or agriculture, those are both more regulated, not more, actually, healthcare is
Obviously,
probably
healthcare is
less
regulated,
regulated.
but yeah,
Yeah.
but they're more used to. But I mean, if I can just touch on that, when you think about the sophisticated surgery as it is, most doctors are using augmented supplies as it is. You even go to your dentist, right? They're augmented, right? I mean, in some ways, right? They're using magnification. There's all kinds of little tools. So I think they've been conditioned and we have been conditioned to accept it. You're talking about industries that have been so manual or so just machine operated that they can't realize and see the future yet, right? Isn't that what you're really saying?
Also, there are so many people, like operator of a crane. Okay, so the crane, there is small booth. Somebody is sitting with joysticks and is controlling when to pick the parcel and to bring it to seventh floor of a skyscraper or somewhere. So that the way it operates, the workflow is so much different the way it needs to operate for autonomous crane that those employees are actually worried that they will lose their job. The way the buildings are being built is going to change, and that's a major change. That's not just okay. Let's tomorrow now put the crane autonomous and we're ready to go. And there are many risks that what if the AI does something wrong and it like
Yeah.
hits human
Yeah.
body, safety issues, and
Yeah, you bring up a good point. I mean, I know we're kind of going on a tangent here, but you kind of think through this. You've had, construction standards, say, for the past 50, 75 years. This is how we build buildings. This is how men operate in these dangerous areas. And now you're trying to introduce robotics. And you know what I've seen, particularly in construction, I have seen they look like little spiders. And they go around, at night after the shifts are over, and they're going through and inspecting the work that's been done. So I feel like I've seen that, and that's kind of that's clever, right? Because that's like your QC, like continuous. Well, like you were talking about back with the oil rigs, with the pressurized lines that were being tested for thickness, same concept. And they
True.
were, I don't know what they were checking. I don't know if they were checking the welds. I'm sure they could use.
Well, the thickness of the pipe, because sometimes when the corrosion is there, like the thickness is becoming thinner, and
Yeah,
then there is a risk that the pressure may break the pipe. So that's like
right.
the predictive maintenance kind of stuff.
Yeah,
Anyway, yeah.
predictive maintenance. And I think they're doing that now in construction. So I think is perhaps what we're going to see is a gradual increase of robotics in maybe lower risk areas, if we will. And that'll kind of pave the way to take bigger steps, bigger leaps, because you're on the forefront of it. I mean, you're already, like you said, you've got the spine right now.
So Tactone is an enabler technology. We are not building the robots themselves. That's what our partners are building, are doing. And now today, honestly, it's not yet, the technology is not yet fully ready for this mass deployment. It's not only the adoption issue, but also the technology itself is being developed. For example, let me bring one example to give a better understanding what is not ready and what is ready. So, for example, if you have this NVIDIA brain on those boards and you start to operate fully relying on AI technology, which today those are called VLAs or VLMs, which is visual language action models. Now, there are several companies building those VLAMs and VLMs. Now, if you rely on that and it starts to do everything based on this closed loop, like seeing, acting, the speed of operation is not going to be as quick and as high quality compared to the human being in the loop. Now, that's one thing.
I
And
see.
that's why our technology is helping, because we have those two things combined on the same board: the traditional control algorithm and the modern language models and VLMs that are running on the same PCB.
So
On the
instead
same
of just a closed loop VLAM or VLA, however you describe that, you can then add the human intelligence to quicken
It's
the process of
actually not the
learning.
human, but the traditional control algorithm, which is like, let me bring the example on the crane. When there is a crane and there is human body, like human crane operator with his
Yeah.
joysticks controlling. So the joystick is being controlled by those VLMs, by NVIDIA. Okay, but when I push with my joystick, which means okay, jog up the motor, at that moment of time, this jogging is now shifted with much higher speed closed loop rate with another PCB, which is from AMD. AMD is another company that
Yeah.
probably
AMD.
everyone has heard. Now we're using another term, FPGAs, which is a special type of a chip that can be reconfigured on the hardware level. Now, those two chips together is what is the great value. There is still no human in the loop. There is no human, but the technology is, we're using those two different technologies
I see.
combined on a single board to solve the problem of the low speed with the VLMs.
So you
I hope.
turned into an engineer. That's see, I'll just tell you, I know some of my listeners understood what you said. That went over my head, but that's okay. I'm your classic businessman. It sounds like, again, to kind of paraphrase, it sounds like the technology is well in advance of adoption, but that the techniques you're using is enabling for faster learning.
Integration and like reducing the lead time to make those robots. That's the biggest value.
Right. And that's the problem you're solving with this is it's a faster configuration to the environment. That's the takeaway, yes?
Yep.
Yeah, that's incredible. So I guess as we look ahead, and if you had to just kind of imagine, I know you said maybe 5 years we'll see more of this, but what do you think the future timeline would be for more of this kind of robotic / human replacement? There's this, people are very worried about this. You know, we hear this quite a bit. What do you think is the timeline on something like this?
I think it is going to be around 5 years before we see the real adoption on particular field industries. And I don't think we need to worry about this. Honestly, there has been so many revolutions of industrial revolutions over the last 100 years, century. And so I think like this one is not going to be much different. And we always find much better work and more enjoyable. Like we're not now
It's true.
doing this on the boat, or I mean,
It's
so
totally
that's
true.
happening. So I'm very much positive towards the future rather than thinking that okay, we are going to eliminate it by the robots or something like that.
See, and that unfortunately, that is the narrative that people hear. Because the CEO for Tesla and Nvidia, they come out and they talk about just the speed of AI and how things will be replaced. And I just think it makes people a little unsure, and it's good to hear from an industry expert that, as you said, I think these industrial revolutions, people adapt. They are able to find higher and better uses for themselves. But, my advice to people is continue to learn. I mean, we are obviously moving into a world of robotics. So you do need to continue to upskill, right? You can't just,
Sure.
if you're just in the manual labor side, but you need to start finding ways to level up your skills. Yes.
Sure.
I would say so. Well, this has been fantastic because I feel like you're the kind of part of that core infrastructure, that technology enabler that we need to see, so the world of robotics can do more for our warehouses, for our manufacturing plants, because all of that benefits the workforce, and that's what I'm interested in. Because I'm in sales and marketing for a mid-sized staffing company, and we want to see our workers safe. And you're at the forefront of helping create that. And that's why I wanted you to come down to have you kind of introduce to the world Tacton and the kind of the spine, if you will, right behind the intelligence that's happening in our warehouses, in our plants, in the field. It's fantastic. Raphael, great to talk to you again a little bit more here live with the crowd.
Thank you so much, Tony. Thanks for inviting and thanks for having me.
It's been a pleasure, and thank you for keeping it at my level.
I hope so.
You did it. We'll talk to you soon, Raphael.
Thank you. Goodbye.